All right, a huge welcome to all you students from Tarleton State University's Dr. Sam Pack College of Business. Today, we're going to jump into a preview of Chapter 5 from your Network Plus guide. Now, before you even crack open the book, we're going to talk about something that might seem, well, a little old school, the physical cable. But here's the thing, it's the unsung hero of our digital world. I'm talking about the actual foundation for everything from your Wi-Fi to the cloud. So let's get right into it.
So, here's our roadmap for this quick explainer. We're going to start with why physical networks are still so strategically important. Then, we'll get into the basic rules of how data actually moves. From there, we'll dive into the big debate, copper versus fiber. We'll even walk through a super common troubleshooting situation you could literally face on day one of a new job. And finally, we'll wrap up with a guide to help you really focus your reading and nail this chapter.
Okay, let's kick things off with something that sounds like a total contradiction, right? We live in a world that's absolutely obsessed with wireless, Wi-Fi, 5G, you name it. So why on earth are we going to spend our time talking about physical cables? Well, because as you're about to see, they've never been more important.
And that's the big question, isn't it? Here's the simple, kind of shocking truth. Wireless isn't really wireless. It's a bit of a myth. Think about it. Every single Wi-Fi signal you use, every app you open on the cloud, every video you stream, it all eventually hits a physical wire somewhere down the line. That means the speed, the stability, everything you love about your wireless connection is totally dependent on the quality of the cables you can't even see.
So, here's the bottom line for your career, and this is really important. Businesses are constantly demanding faster, more reliable networks. And mastering this physical layer, it's not just some basic check-the-box skill. No way. It's what's going to separate a good network pro from an amazing one. This is the absolute bedrock you'll build your entire career on.
Okay, so we've established why these cables are so crucial. Now let's get into the nitty-gritty of how they actually work. We're going to look at the fundamental rules of the road for data. I want you to think of it like, well, like the physics of a giant digital highway.
Now, getting the difference between these two is absolutely key. Bandwidth, that's your potential. It's the 8-lane superhighway you see on a brand new map, pristine and empty. But throughput, that's the reality. That's the actual traffic flow during rush hour with a couple of accidents and a construction zone thrown in. And as a network professional, your whole job really is to bridge that gap between the dream and the reality, to maximize that real-world throughput.
And these right here, these are the classic traffic jams on our data highway. First up, you've got noise. This is just unwanted interference, kind of like static on an old radio. It can come from other electronics, that's what we call EMI, or even from crosstalk between cables running side by side. Then there's attenuation. That's a fancy word for the signal just getting weaker and weaker the farther it travels. And finally, latency. That's the delay, the total time it takes for your data to get from point A to point B. Your mission, should you choose to accept it, is to design and build networks that keep all three of these as low as possible.
All right, so if those are the rules of the road, how do you pick the right vehicle for the job? Let's take a look at the main tools you'll have in your trade.
Basically, your toolkit boils down to two main options. You've got your traditional copper cables, you've definitely seen these before, and you've got fiber-optic cables, which are pretty cool because they send data using actual pulses of light. And believe me, each one has a very specific and very important role in any modern network.
Okay, think of this table as your strategic cheat sheet. On one hand, you have copper. Copper is the reliable workhorse, right? It's cheaper and it's plenty fast for most day-to-day office stuff. But, and it's a big but, it's limited to about 100 meters and it's vulnerable to that electromagnetic interference, that EMI we talked about. Then you've got fiber. Fiber is the Formula One race car. It costs more, sure, but it is totally immune to that electrical noise, and it can blast signals for miles, literally kilometers. That makes it absolutely essential for connecting buildings or even whole cities. As a network designer, you're always going to be weighing these trade-offs to figure out what's best for the business.
All right, let's switch gears. I want you to imagine this. It's your first week in an entry-level job. You're on the help desk. The phone rings. A panicked user on the other end says, "The network is down." So, what do? Where do you even begin?
Okay, before you start diving into complex software diagnostics, you always start at layer 1, the physical layer. I'm serious. First question, are the little LED lights on the network port blinking? Second question, is the cable plugged in nice and snug on both ends? You would be absolutely shocked how many network down calls are just a cable that got kicked loose. Now, if the simple stuff doesn't fix it, then it's time to grab your toolkit.
First up, we've got the toner and probe kit. Picture this. You're in a wiring closet, and it's just a spaghetti mess of hundreds of identical-looking cables. How do you find the one you need? Well, this tool is your secret weapon. You attach the toner to one end, and it sends a specific sound down the wire. Then, you take the probe and just wave it over the bundle on the other side until you hear the tone. Boom! You found your cable in seconds. No guesswork. It's all about efficiency.
Next in the toolbox is the multimeter. The best way to think about this is like it's a doctor doing a health checkup on your cable. It measures the basic electrical properties. It can tell you if there's a clean break in the wire, that's an open circuit, or if two wires are accidentally touching, creating a short. It's all about checking the basic electrical health of that connection.
And finally, there's the cable tester. Now this one is super important because it doesn't just tell you if a cable is connected, it tells you if it's connected correctly. See, inside a standard network cable, there are 8 little wires, and each one has to go to the exact right pin on the other end. If you mess that up, which is called improper termination and happens all the time, your network will fail. This is the tool that spots that mistake instantly.
Okay, as we start to wrap this preview up, I want to make sure you're totally prepped to go into the chapter reading with a real sense of focus and purpose.
So as you read, I want you to really zone in on a few key things. First, the TIA/EIA termination standards, 568A and 568B. These are basically the recipes for how to wire up a network jack. You just have to know them. Second, those tables, especially 5.3, 5.4, and 5.6, they break down all the different categories and standards for both copper and fiber. They're your guide to what each cable is capable of. And lastly, really dig into the difference between single-mode fiber, SMF, and multi-mode fiber, MMF. Knowing which one to use in which situation is a huge design skill. Honestly, mastering these specific points will be massive for the exam and, more importantly, for your actual career.
And I'll leave you with this to think about as you're reading. We are always pushing for more speed, right? Faster and faster. So, as we go beyond 100 gigabits per second and even faster, which one of these big physical roadblocks, distance, noise, or just plain old cost, do you think is going to be the biggest challenge for engineers to solve? It's a really big question, and who knows? One day, you might be the one to help figure out the answer. Thanks for tuning in.